Okay, so here I have the hour starting. So welcome everyone to the Madinas BOF. Madinas stands for MAC Address Device Identification for Network and Application Services, and this is a non-working group forming BOF. We're going to be chairing Juan Carlos Zuniga, myself, and Carlos Bernardos. Next slide, please. So a few points here about the tips and etiquette for this meeting. So please, if you want to join or raise your hand if you want to say something, join the queue by raising your hand in the Meeticle. It's the little hand on the top left that you see there. That way we will acknowledge you and let you speak. Please mute your microphone unless you are speaking, and preferably turn off your video. If ever you want to have some information about the Meeticle features, we have some links there. The note well, as usual, this is an official IETF meeting, so please make sure that you understand that participating in this meeting, you agree to the processes and policies of IETF. Sorry, if you're aware that IETF contribution is covered by patents or patent applications, please let us know. As participant or attendee, you acknowledge also that you are going to be recorded. Personal information that you provide to the IETF will be handled in accordance with the privacy statement, and please be respectful with other participants. If you want to have more information, there are some links there about the BCPs that will give you more details. Next slide. So as a reminder, minutes are going to be taken. So we have minute takers already assigned. This meeting is being recorded. Your presence is logged. There were some questions there. So yes, your presence is already logged by logging into Data Tracker. The scribes, please contribute the minutes to the CodeMD. You have the link there, and you also have a link on top of the Meeticle meeting. The recordings and meetings are public and may be subject to discovery in the event of any litigation. Okay, so moving on to the agenda, we're going to have a couple of minutes here discussing the agenda and the way we want to work this BOF. Then we are going to move into the background of the MAC address randomization. For this, we're going to have Amelia Andersdotter presenting the background and status about MAC address randomization activities in IEEE 802 and WBA, followed by Dave Feller talking about MAC address randomization in Windows 10. Then we're going to have some minutes for clarification Q&A only on this background part, so that you can get those out of the way as we move on to the next section, which is going to be the use cases. For this, we're going to talk about home network, community Wi-Fi, hospitality, cloud management use cases that are potentially impacted by the MAC address randomization. And for this, we're going to have Jason, Malay, and Chris presenting. Then we're going to start, and we're going to have enough minutes for you to have clarifications about the details of these use cases before moving on to the open discussion for this topic. Then we're going to talk about what is the interest of the group and what potential next steps we may or may not want to take. So do you have any questions about the agenda so far? Okay, so can we move to the next slide, please? So the purpose of the BOF, first of all, is to inform the IETF community about the latest MAC address randomization activities and purposes. So MAC address randomization, as you may know, it's not necessarily something that happens inside IETF because it's in lower layers. But of course, as part of the stack, it affects some of the services that are provided by protocols defined in IETF. So then we're going to present the network and application service related issues that are related to this MAC address randomization activities. And we want to finalize, identify whether any actions are required at the IETF. In this case, actions it's open discussion. So it may be coordination with other SDOs, documentation of these use cases, identification of existing solutions that may be there, or gaps that may need to be solved. Are there any questions about the scope of the BOF? Okay, I see no one raising hands here. So if that is the case, then moving to the next point in the agenda, we're going to have Amelia presenting. Oh, sorry, yeah, Eric, you want to say a few words?
Yes, thank you, GC, for the introduction. For this BOF, I will be the responsible AD. We will wait and see what's happening with the BOF later. I would specifically like to thank the initiator of this BOF, so it's you, Jason and Jason, as well as Yari and Stephen that helped to scope a little bit better this BOF. And of course, everything here is done with the IEEE coordination. And I've seen a couple of people that are also representing the IEEE here, including you, JC. So, and thank you for the two chairs for accepting to take this BOF chairing. So thank you, Carlos, and thank you, GC. That's all for me.
Thanks, Eric, for that clarification. Yes, so perfect. Moving into the next topic, which is Amelia, that is going to talk about what has been done at IEEE and elsewhere regarding MAC address randomization. We have Amelia on the...
I don't see her on the participants.
Okay, so Eric, do you want to say something? Otherwise, we can probably present the slides on her behalf.
Yeah, I was about to say that indeed the best thing to go forward is to go through the slide, hoping that she will be joining. GC, as far as I know, you are also quite, this is your draft first, and it's also quite IEEE focused, and you were as well part of the IEEE effort. So maybe you are the best person to take the role over.
All right.
That's important. It needs to be done before the use case. So better do it.
Yeah, definitely. Definitely. Thanks. So can we move to the next slide, please, Carlos? So then starting with some history here, the whole work on privacy and MAC address randomization started after, if you remember, the Strint workshop that took place a long time back in at the IETF, IAB, and W3C. And from there, there was some follow-up work that where we realized that layer 2 identifiers that were assigned uniquely to devices were posing a privacy threat. And then the work was moved, of course, to IEEE 802, where they actually are the ones defining MAC addresses at the rack in IEEE. And of course, then since then, several projects have started working on how to solve the issue of MAC address randomization. We had different issues where the MAC address randomization was sent in plain text. For instance, when searching for an SSID after some period of time actively, then passively during the communications and so on. There's extensive research, and then in the draft we have plenty of references that show all the different issues that show from this MAC address randomization. Can we move to the next slide? Then, well, I've already mentioned this W3C IAB privacy tutorial that was given at the IEEE 802 plenary. It's thoroughly documented. And then that led to a number of initiatives, which are also mentioned in the draft. If you remember, around 2014, and so we had some experiments at IEEE and 802 meetings where we were randomizing MAC addresses and trying to see the effects on different services. And since then, now MAC address randomization is a default privacy feature in major mobile operating services systems. Can we move to the next slide, please? Then the work at IETF inspired a research project, which is Project 802E. This is the study group in this work mapped the privacy features. So basically, it was privacy recommendations for all IEEE 802 protocols, recommended practices and considerations that can be used when defining IEEE protocols. Afterwards, there was also the 802C slab that assigns dynamic addresses to devices upon need, and this is meant for industrial sensors and so on. Next slide, please. There was also the IEEE 802.11aq amendment, which introduced robust recommendations for MAC address randomization. And now, just this at this time, it's happening in IEEE 802.11. There are two PARs, project authorization requests, 802.11bh and BI, that are going to look at privacy features and network operation in absence of clear test permanent layer 2 identifiers. So very relevant to this work. These two are just starting now. So is a perfect time basically to start talking about these topics in IETF as well. Can we move to the next slide, please? Then we have WBA that is also relying on a higher layer identity management, which is kind of an extension of the Passpoint in Wi-Fi Alliance, and that may ring the bell for people that are familiar with edu-ROM architecture. So the idea there is also to make sure that there are ways to authenticate users and allow them to connect to Wi-Fi networks more freely in different domains. Next slide, please. This table shows just a summary of some operating systems and some of the features that already use MAC address randomization. As you know, there's Android, iOS, and Windows already using MAC address randomization. And well, you have there the details. Basically, operating systems today use dynamic MAC addresses or randomized MAC addresses to connect to networks, but they don't do it in a standard way. There's different ways to do it depending on the operating system, and I'm not going to talk about the details because then we're going to have more later on by Dave Taylor, who's going to explain how this works in Windows, and we're going to hear in the use cases. But if ever you want to have more details, there's a reference there. Next slide. So comments and questions, as I mentioned, what we would like to take after we finish with the presentation of this MAC address randomization background, history, and the presentation from Dave. So if you don't mind, let's move now to Dave's presentation, and we will take comments and questions for both right after.
All right, testing audio. Can you guys hear me okay? Juan Carlos, can you hear me?
Yeah, you're good.
Okay, great. Just thanks for racking. All right, so as Juan Carlos mentioned, I'm going to talk about what we did in Windows 10, at least, I don't know, 5 years ago or so. And you'll see a lot of it overlaps with what Juan Carlos showed for iOS and Android. But I guess we wanted to have at least one drill down into examples, and a lot of these will be common across operating systems. So next slide, please. All right, so I'm not going to talk much about this one other than things are configurable, which I'll get into in a moment here. It does depend on support being in hardware and drivers, and so it's almost always present, but if you have an odd hardware or old driver or something like that, you might not see it. But otherwise, there's configurations on a global basis, in other words, on a per Wi-Fi interface basis and per network. So next slide, I'll get into the details here. Okay, so there's two types of settings. By global, we mean no matter where you are on your Wi-Fi interface. As you roam around, global just means as I roam around anywhere on the globe, that's what the global setting is. And so there's a setting that applies to scans for nearby networks, right? And so in case you're new to the problem space, one of the problems is this: just when you scan for Wi-Fi networks, the probes go out, and the probes come from a MAC address that is like an identifier. And so in various public locations, they monitor the MAC addresses of the probes. So even though you're not connected to any SSID, you're still broadcasting a unique identifier. And so what the global setting does is it applies, first of all, to these probes that say, when I'm not connected to any SSID, right, all the probes are coming from a random MAC address. And every time you connect or disconnect from any network or you restart the device, that random thing changes. Okay, so this is the main tracking danger. Now, of course, this is only one of the pieces of it, but this is probably the most popular way of tracking people because you can track that even when they're not connected to your network. Okay. Second part of the settings has to do with what happens when you do connect to an SSID. Okay, and so when you do connect to that SSID, then by default, the same address is used. So if you disconnect, you reconnect, you disconnect, you reconnect, each time that you connect to that particular SSID, you'll get the same MAC address, right? This is the default. And of course, you can forget the network and sort of clear that state. But once you connect to something, it creates a piece of state that says, what's the MAC address I'm going to use for that network, okay? Now, the reason for this is keeping use the same one over time. And as you'll see on the very bottom here, there's 3 different behaviors. I'm just grabbing the default one. And so the main reason for this is it's a trade-off between privacy and usability, right? Now, there's a number of places, you know, hotels and hotspots and things that make you fill out a form when you first connect, or even charge you when you first connect, right? And if you were to change the MAC address every time you connected to that network, you'd at least have to fill out a form, if not pay, every single time that you change your MAC address, right? And so that's the usability aspect that users don't want that. And so instead, the very first time it will generate a random one, and subsequent ones will reuse the same one as the first time so that you won't have to re-go through that form or paying or whatever. So that's the kind of the middle ground category, okay? Now, any existing connection, so if you change the behavior, but you've already connected to, you know, at office or at home or whatever, it will continue using the one. In other words, once you join an SSID, it's remembered, even if it was the physical one, it's remembered that with that SSID until you forget that SSID. So that's the global setting. By global, I mean, again, not SSID specific. I mentioned that once you connect to an SSID, right, it remembers the state for that SSID, right? What's the MAC address that I'm going to use for that SSID? So there's settings that you can store in that SSID specific state, okay? There's actually 3 different settings that can be used, okay? And this is configurable by users or admins. The first one is to say off, which says use the permanent hardware MAC address, okay? Means don't use MAC randomization. And an example of networks where that's important is, let's say you have a corporate network that's using the physical MAC address for inventory tracking, right? And so they won't let you on the network unless you're getting on the network with the hardware MAC address that they've inventoried, okay? That would be an example of where that's kind of necessary, right, on such networks. The second option is equivalent to the default one, which is use the random MAC address the first time that you connect. In other words, use the same one, and it's random when I first connect, and then just store it there and you reconnect with the same one, right? That's the default option when you're using MAC address randomization. But then if you have a case, let's say you go to a internet cafe or a coffee house or something every day, right? You might say, well, maybe I don't like the fact that they can tell that it's me every single time I appear there on this public network. That's what the change daily is for. It says every time that I connect, if I'm connecting on the same day as I stored the MAC address, then keep using it. But if it's a new day, regenerate a new one. Okay, and so that way I don't have to refill out a form or pay or whatever if I'm connecting back the same day, but the next day I will. Okay, and so that one's meant for cases where you're really worried about, hotspots or something tracking you that you visit daily. And so the point is, all three are configurable options, and each one is appropriate on a different category of network. And since there's no clean way to know what the network's intent is, then we ask the user, but it's also configurable on an admin basis. Next slide. Last slide. Okay. Now, specifics, the MAC address is a hash of a secret. The SSID, right, you saw in that table that Juan Carlos showed that Android and iOS differ by whether it changes by SSID or BSSID, right? Windows is the SSID. And the MAC address uses a cryptographically random API, and so it really is cryptographically random. But of course, since it's generating MAC addresses, it makes sure that the bits are set in the high bit to say that it's locally administered and it's a unicast address. So far, even though it was in there since at least 5 years ago, it's not enabled by default. And that's because there's still reports that there are some networks, and no, I don't have numbers. I wish I did. Maybe somebody does, but I don't have numbers on. There's still some networks that have problems when you have randomization. If you try to turn it on, some networks with MAC address filtering or hotspots may have problems, and so that's why it's not on by default. We would love to turn it on by default. We're just not there yet, but we hope to get there once the numbers allow. So the times that it's most likely on is where there's clueful users like people sitting in this audience that turn it on, or more likely when there's an IT manager that turns it on for all devices. So if you have corporate laptops and things that roam around, those are the ones that most likely have it on because the IT managers will turn it on with any of those settings. And so that's the brief overview. Happy to take questions. Christian Wiedema, 5 years ago when we first did it, or shortly after it was done, wrote this blog article that has a slightly longer explanation, but I've now pretty much told you all the highlights that's in that article. So. The slides here is still accurate to what's shipping in Windows 10 right now. So there you go. That's my last slide. Happy to take questions, but otherwise, back to you, Carlos and Juan Carlos.
Thanks a lot, Dave. So Eric, you're on the queue. Okay, no, probably. Right, so we see Daniel.
Hi there. Thanks for this presentation. In the list of specifics here, you mentioned the address calculation is a hash of secret SSID and connection ID, and I'm sorry if I missed this. It's pretty early for me. Is that a stable secret across the lifetime of the machine, or a new secret every time?
I am not the best person to ask that question, but my understanding is every time that it generates a new MAC address, it uses all the entropy provided by the crypto API. And so, in other words, my belief is that the entropy isn't a one-time entropy, that it's each time, but I don't know that for sure. I can follow up and get you an answer if you need it.
That would be great, because I mean, if it's new entropy every time, it's not clear to me why you would need to do this hashing even, like what the point of the hashing is. You could just apply the entropy directly.
Yeah, you're right. It could be that it's the same secret that's generated at machine install time. That's possible. I'd have to check. I didn't implement this myself. I'm just reporting out on it. So sorry, I don't know the answer to your question. But I get your point. Yeah, you're right.
Yes.
Sorry, was there somebody else?
Yeah, we have Glenn.
Okay.
Thanks.
Yeah, Glenn.
Can you hear me okay?
Yep.
Yes, we can hear you now.
Yeah, this is Glenn Parsons from Ericsson. So I just had a comment on the 802 aspects. I just wanted to mention one particular ongoing activity that wasn't mentioned, which is called the 802.1 AEDK activity. The title of this is MAC Privacy Protection. So this is an amendment to the MAC security standard in 802.1, and it's specifically defining an encapsulation format that can carry confidential protected data within a frame. And so it would hide the original user's MAC address as well as the frame sizes. And so the frames would be padded to some consistent or random size as well to protect the privacy. So this is a project, MAC privacy protection, that's currently underway as well. I just wanted to note that.
Great. Thanks a lot for that. Stephen?
Hi, Dave. Just a question about the default on. Can you say anything about the kind of factors you would consider before going to default on for this? I guess you can't commit to anything or give specifics, but just a guidance. What kind of things would you be expecting before turning it on as a default?
Sure. Can we go back one slide, Carlos? Okay, so I'm going to look at, if you look at like the three options down at the bottom, I said each of these would be applicable to a different type of network, right? So the first one was an example of that would be a corporate network that uses MAC addresses for inventory management, right? And so you could say, well, on would break that, but you can also say if I'm using it for inventory management, then maybe that's a case where it's IT managed anyway, and so you could have the IT administrator would send out off in that particular case and say, so that one is not that big of a deal unless you start having things like inventory management on things that are not managed. And so if you have a BYOD device, meaning you have your own laptop and you bring it into work or whatever, and it only works if you've registered the hardware MAC address ahead of time, then that would have problems there. And so I'm just saying, what are the gaps or things that you need solutions to address, even if they're social workarounds or tooling workarounds, right? Second type of network is the ones for on would be there, right, which is kind of where we want to get to as the default, right? And so there, the only issues that I know of are the ones that were hinted at on the next slide, which is if you have some public hotspot or things. So an example would be if there exists hardware out there that doesn't work right, if the MAC address that you use in the probe is different from the MAC address that you use after connecting, right? So if for some reason they've made it only work when those two things are equal, then of course on would have a problem. And once that set of hardware, if problems like that, once they go away, because what happens when you say, if you change the default, or if you upgrade, you upgrade an operating system to a newer version that has a different behavior, if you change that behavior, people think that the operating system must be broken because it no longer connects and it used to, right? And so how do you prevent those regressions for cases that it was working before? Now, at least once you've connected to something, we store the MAC address that you're using, right? So hopefully on an upgrade that you've remembered the fact that you were using the physical one, which it does. And so if you were using the physical one before, then you'll continue using the physical one until you change the network setting or until you forget the network. And then lastly, change daily. If you're thinking about, the Starbucks style networks, you might be worried about people tracking you. I think it's really the same thing. And so I guess that's my long answer, but hopefully that's enough to answer your question, Stephen. So it's really, once there's existing tools, once the observed deployments of problematic networks becomes negligible. And the statistics might be different for something like mobile OSs, only because the types of networks that you connect to might be skewed compared to what, say, a laptop connects to, right? They'd be close, but they wouldn't be exactly the same sample set. So.
Okay. Thank you very much. Are there any more clarification questions for this first part? Oh, yes, see Dan.
Yep, it is done.
Would you like to unmute? Yep,
Yeah,
we can hear you.
thank you. Okay, great, thank you. Thanks for this presentation, Dave. So does Windows 10 do the other things that were specified in 8211AQ when you randomize a MAC address? Namely, reset the sequence, the packet sequence number, and reseed the OFDM scrambler?
I don't know the answer to that offhand. My belief is that we change all the things that you'd want to change at the same time, right? Now you're asking about very specifics that I don't know the answer to, since I'm not one of the implementers on this particular team, but I work with them, so I don't know the answer offhand. But I know we do things like when you change the MAC address, you want to change the IPv6 address, even though the IPv6 address is not derived from the MAC address, right? So you change the things that could be correlated all at the same time, rather than at different times, which would allow you to introduce correlations between them. And so my belief is yes, but I can't authoritatively say that yet. Yeah, so.
And for things that are not really layer 2, but sort of like 2.5, like the DHCP client ID, is that, do you change that as well?
Those are all great questions. I don't know the answer offhand, but since Christian used to be the person that was driving this, and which is why he wrote the blog on 5 years ago, he could probably tell you off the top of his head. My belief is that Windows has spent a lot of time on the privacy aspects over the last 5 years and knowing what to change, that when you turn it on, that it's trying to do the right thing with all the different identifiers. So, gosh, I hope so. If not, then we'll fix it, but I hope so.
Okay, thank you.
Thanks, Dan. We're going to move to the next in the queue, and we're going to cut the queue with Michael. So next
Hello.
is, yes, Tiro.
Hey, Dave, thanks for the presentation. I mean, I had a few clarifications. How do you make it easy for an user to, for example, enable this randomization in untrusted networks like coffee shops, airports, and then enable this in trusted networks? For example, I enable home network security, and I want my home network security service to enforce policies per device just to identify anomalous behavior and various such activities, right? So how does a naive user, right? I mean, would enable these options or disable these options on a per network basis?
Yeah, that's a good question. If you were to go into Christian's blog, which is linked on the last one, that actually walks through the specific UI where you can find it. Yeah, if you would look in there, because there's screenshots and stuff in there. So that will answer your question. But is it easy? Well, it's more for an advanced user because it doesn't say, hey, would you like to be private on this particular network, right? There's a button you can click on that will actually take you to the settings that you can change it. And so is it easily discoverable? Well, it's not hidden, but it's not in your face, right? And so it could be better. But it is there when you connect, or when you look at the settings for any particular SSID, you can find those 3 settings in the Wi-Fi settings for that SSID. So it's not hidden, but it's not great. Could be more discoverable, but it's not. There's a natural path to click on to get there, and again, you'll find the details. You'll find the walkthrough in the actual blog there.
Thanks, Dave.
Michael?
Dave, when your Windows 10 is doing WPA Enterprise or 802.1x or whatever you want to call it, are you using the same MAC address as you would to connect? And how do you know what network you're really connecting it to at that point?
I'm not going to be able to answer your question authoritatively again, because now you're asking a very detailed question, and not being the implementer, I don't know for sure. And I can tell you, you're not going to find that particular answer in the ones that I don't know. The answers are also not in Christian's blog either, which means I actually have to ask the devs who couldn't make this particular meeting. So I'm presenting their slides on their behalf. But
thank you.
So I don't know.
Okay. Well, thank you very much for that, Dave. So we're going to stop here for the first part of the BOF, and we're going to move to the next one, which is the use cases. And just as a reminder, again, we're going to go through the use cases, then we're going to take clarification questions on the use cases before moving on to the open discussion. So now we're going to have Jason, Chris, and Malay present the use cases.
All right, great. So my name is Jason Weil with Charter Communications. What we did is when we started this project, we got together a number of ISPs to come up with use cases. We actually ended up with like a dozen or so that we tried to winnow down to a few high-level ones so that it wouldn't we wouldn't spend the whole time talking about use cases on this BOF. So I'm going to cover some of the ISP use cases and then hand it off to Malay, and then we'll follow up with Chris at the end to get an overview. Okay, first slide or second slide. All right, so yeah, so the first use case is access control based on MAC address. This is pretty common across most ISPs. I know Charter does it. I know many other ISPs that do it as well. So for this use case, you know, CPEs we create we use the MAC address as an identifier for devices on the network, and then we use that as access control for that network, offering things such as, you know, pause, give a device nicknames, things like that. And then we also do, it's also used for DOS mitigations in some networks, for filters, putting filters onto CP devices, and obviously when I talk about CP devices, I'm talking about the home gateway routers that we deploy in home networks. And then a lot of this falls underneath parental control as a service. Okay, next slide. Another use case is setting up using DHCP to set up a sticky IP address for services, such as static port forwarding or setting up a DMZ. A lot of this ties to IPv4 addresses more so than IPv6 addresses. But it's common for, you know, if you want to RDP into a device in your home, or if you have a child that hosts a Minecraft server, this is a good example of doing that, using the DHCP server to tie an IP address and port forward to a MAC address. All right, next slide. So this is more of a use case of impact to MAC address rotation, and a lot of it depends on how often the MAC address is rotated. But some DHCP pools are fairly small on some devices, and so if every time you change the MAC address, if it results in a new IP address, and then the old IP address is still stuck in the DHCP pool, depending on how many devices you have on the network, over time you could run out the IP address pool, and the new devices would not be able to come onto the network. All right, go ahead, next slide. So there's a whole slew of use cases that fall underneath this. I consider like diagnostics along with network management. So this is how ISPs help troubleshoot customer connections. A lot of times we'll use the MAC address as an identifier for a device to help either try to figure out how much usage it's doing, or if it's causing problems. You know, possibly if it has malware, how do we track that coming from that device? So there's definitely a need here. Well, there's argument for a need here for a persistent identifier to help with doing this. There's also, so typically the MAC addresses per SSID is fine in this case, but there is a use case where if you move a device, say if it's on Wi-Fi as well as a mobile device on the same network, trying to track that device across multiple networks, there is an argument, or there is a use case there where you need to go beyond just the per SSID if you want to make that use case valid. Yeah, that's good. We'll go to the next slide. We can ask. I'm sure there's lots of questions that might come out of this, so feel free to ask away. All right. So this is it's kind of like a follow-up to the parental control / using the MAC address as an identifier for advanced in-home features. Like we use this today for, like I was saying before, like pausing networks, schedule pause, grouping devices. Say all the devices that belong to one of your children, you might want to put in a group and disable those at a certain time each day when it's time to go to sleep. There's more advanced things you could do as well. Things like speed boost for certain devices. There, you need to know the device's ID, and then what do you call it? Parental controls, like I discussed as well. So if you want to block content, you can. Some systems that are deployed today use the MAC address as the identifier, and then more advanced more advanced features to figure out where that device is going, and then create like a whitelist or blacklist to block that type of content. Okay, I think that covers most of the ISP in-home use cases. So I'll hand this over to Malay for the next portion.
Malay from Plume. So a lot of home network management use cases are also go in line with the ISP use cases like the previous slide, which was mentioned. And while doing providing such features, we manage the devices from the cloud. So that means that we have and we can't really discard the devices which have randomized MAC addresses, because there is a chance that user would like to add them to a particular person profile, like if the MAC address is fixed by when associating to the SSID. So that means that if the MAC address was changing after associating, then the database across the entire network increases rapidly, and that would have detrimental effect on the management of the database. And then also the clustering of the cloud devices which are referring to that device, that database will also be affected. So all of the management complexity increases by then. Next slide, please. So randomizing MAC address would lead to the sign-in to that public Wi-Fi each time, even if the device is in the same area. Next slide, please. This goes about, this specific feature is about the roaming of the device across the public Wi-Fi networks. Say I have a specific network cell phone plan which lets me auto roam to that cell phone network providers Wi-Fi networks. Then if I'm walking around in a community, then my MAC address would be used to efficiently roam between the networks. But if my MAC address is randomized per BSSID, then each time I'm walking to the next home, which is providing the community Wi-Fi, then I would have to go through the process. The network would have to go through the process of creating a new tunnel, and that would be also be detrimental to the experience which I would be having. Say if I'm doing streaming, then I would see effects on the internet experience on just by roaming around, walking around a particular location. Next slide, please. Experience, quality of experience for that particular device, and it happens for the Q data, and then measurement of QoE would happen and then would be verified for okay. I think Chris can take over now. Thank you.
Yep. Hopefully you can hear me. So when you have an access point with multiple frequency bands, currently, well, the old way of doing things is the client always chooses which band to connect to and which access point to connect to, which means you can end up with crowding of multiple devices on one band, but the other not really being used. So in order to remedy that situation, there's something called client steering. Now, the new Wi-Fi standard has something called multi-band steering, which does this in a fairly decent way. So it's asking clients for measurements of the signal strength of the different bands, and then advising them which is the best for them to use. But for older devices, there has been a legacy mechanism that's used, which is this is something that's only implemented at the access point end. So it's really the access point looking at the signal strength that it sees from the clients, and then if it wants them to move, it's essentially saying go away, and hoping that they reconnect on the other one. So if you've got that kind of older client, access points may then have to compare the signal strength they see on a probe request on one band with the signal strength they see for data traffic of that same station on another band. Now, if those two use different MAC addresses, then the access point can't then determine that the probe request is from the same device and be unable to perform that client steering action. The other complication here is the access points also need to record which clients do not respond well to the legacy steering attempts, because essentially, if you're just saying go away, some clients will take the hint and will reconnect elsewhere, but others will not. They'll just keep trying, and so the access point need to track which clients do that, and essentially stop saying go away. So this requires an identifier that is reasonably persistent, so you can be assured that you know it is that same device that has the problem. Pre-association steering may also be affected, because if client devices use a different MAC address for the probe to the association, then again you can't use that in order to influence where they connect to. Next slide, please. So that was all the use cases that we have in here. So in summary, when you look across those, today many services rely on the device MAC address being that persistent identifier. So the consequence of the introduction of MAC randomization is that these services will stop working. Some may be fixed by tweaking the implementation, but not for most of the use cases. So essentially, alternative identity solutions are required to enable the services to continue to operate while also preserving user privacy.
Okay, thank you very much, Chris. So we're going to stop here for a sec. So what we're hearing is that these use cases are highlighting issues that people have seen on the network. And just as a clarification, the idea here is not to claim back to fixed MAC addresses again. I think people understand and acknowledge that the new normal is MAC address randomization. Trying not to abuse the term, but still, they are highlighting problems that they have seen on the network related to MAC address randomization that they wanted to bring forward. So before moving on to specific ways to probably solve these problems or solutions that may exist there, we would like to stop here and take just clarification questions regarding the use cases that you have been presented here. Stephen.
Hi, thanks. I have a question for, I guess, Mane. I'm not sure which slide it is, but 2 or 3 back where you were saying that the MAC address is stored in the cloud. It wasn't clear to me what that's being stored for or by whom. Can you clarify?
Particular case, we are basically providing the features, right, like device policies, service policies, and we are having a database, right, of all the device records by help.
Sorry, I mean, forgive my ignorance. I don't know who we is. So pardon me. Okay, I mean, if you can put a link into the Jabber chat sometime, that kind of explains. I still don't really get why, and presumably, all I think about is the kind of dangers of doing that. So I'm not getting the positive benefit of it. So maybe we can clarify it later on.
You are assigning the devices in home to particular profile. Like if there are kids in home, then
Okay, thanks for clarifying.
Next question. Here.
Hello. Hey, I have a question on same question on the cloud resource management. So, for example, assume that there is no MAC address randomization by the operating system, but still an attacker could easily spoof MAC addresses. An attacker could spoof the MAC address of the parent. It could just simply pick a random MAC address and then this entire database that you're maintaining could be DOSed with several random MAC addresses. An attacker could just flood you with that, right? So how do you handle those? I mean, this is no different from how do you differentiate from a genuine OS doing this versus an attacker doing this every few milliseconds?
able to hear me?
Thank you.
Okay, so while we are moving a little bit away from the MAC randomization topic here, have the SSID and password information correct for the home, and then attacker is gaining by spoofing MAC address. Is attacker gaining the profile information? And then gaining access to that particular network, right? There's no additional gain here for that particular home.
No, I mean to
that
say an
can-
infected device, a device which is in the home, let's say a child's device which gets infected and it spoofs the MAC address of the parent to bypass the parental control, right? Or to bypass some other policies that you have, right? MAC seems to be a very weak identity for enforcing any such policies, right? I mean, it's quite easy. You just have, there are several tools to spoof the MAC address, and you just pick your parent's MAC address and, hey, I can now make sure that the restrictions of no internet access or the censorship policies can be easily bypassed, right? So that's a question basically. Any kid can do that today.
Provided,
right?
provided if parent had that enabled. But the child device can also use VPN in that case and still
Sure.
access even
Sure.
otherwise.
Yeah.
Okay, thanks. Victor?
Hi, hopefully you can hear me.
Yes.
Just commenting on the last item that was asked, prior perspective, typically those use cases are pretty easily found because they manifest as out of profile behaviors. So those types of devices can typically be found pretty quickly based on simple policies enabled in the cloud and therefore isolated as necessary. So although that use case does exist, they show a significant out of pattern, which can be isolated.
Elisa?
Yeah, thanks. Juan Carlos, at the top you mentioned open roaming, and I was just curious if you or anybody can speak to the implications of this for open roaming, like whether this creates difficulties or if there's a more robust device identity that's used.
Well, yeah, I was using the slides from Amelia. I know she had some more information, but unfortunately I cannot speak for that. We would like to answer that, but maybe we'll have to take it on the list and ask Amelia or someone else. Sorry.
Okay.
Okay, so if we have no more clarification questions, maybe we can move to the next slide. Chris, would you like to take us through the use case derived requirements, and then we can move on to the open discussion.
Sure. Okay. So, looking at that set of use cases, it's clear they do have different requirements on the identity, which of course implies a number of different solutions may be required. So, in the blue table, we've identified some key features to consider for each use case. We're not necessarily saying what the answers are, but here are some things to think about. So the first one is how long, of course, must the identifier persist? And for some of them, that could be pretty short, for others longer. Also, what level of trust is required between the client and the network? And how confident must the network be that the client is the true owner of the identity? That will vary between the cases. Then it's the same identifier required to be used pre and post association. Next one is the same identifier required on a single network or multiple networks? Does the identifier represent the device, or are we trying to represent the user here? Must the identifier be provided in order to join the network, or is it an opt-in? And finally, the provisioning of any new identifier we create must be low friction. So how could this be achieved? So on the left, we've got that list of cases, and of course, there is a need to define what identifiers could be used to meet those cases. I don't have the answers, but it's food for thought for the BOF.
Right. So this is basically food for thought, and I guess, well, I see you. You want to say something?
I have a question for Chris here. So when you said identifier here, are you referring to the identifier at the upper application layer, or are you referring to the identifier at the packet level, like what similar to what MAC address now doing today?
So who knows what the right solution is? I mean, essentially what we're trying to do here is preserve MAC address randomization, but I suspect in order to meet these use cases, we will need some other form of identifier, maybe multiple other forms of identifiers. And it's the question, some of those could be at different layers. So it's not trying to predict what the solution is, but just to say, yeah, some identifiers are needed. They will appear at different layers. Let's figure out what is the right layer for them.
Okay. Colin?
So I wish I'd sent this to the list ahead of time, but I'm wondering if we have a requirement around user input as well. So for example, when using 802.1x and some of the various forms of that, one of the problems we have for IoT devices and phones, which are basically like phones like a traditional looking VoIP phone, is that there may not be a way to enter credentials on those devices, and that becomes a problem. So I think that like solving this, trying to figure out from a requirement point of view, whether end user input on the device was part of this or not seems to be one of the things that constrains the solution space a little bit.
I would agree.
Stuart, you have a question? Please go ahead.
Last point in the table, provisioning. The provisioning of any new identifier must be low friction for the user. I'd actually like to question that. I think there are use cases in which the provisioning of a new identifier should be intentionally costly for the user so that it is not trivial for users to create arbitrary numbers of identifiers that not only potentially impose a cost upon the network, but also facilitate their, for instance, constantly having a new identity from which to spam or whatever.
Yes, yeah, I can see that could be an issue. Yes. So maybe it's better phrased as consideration of how the new identity ought to be achieved.
I think we need a means of achieving low friction, but ideally we should have a controllable level of friction.
Yeah, that's a good way of putting it.
Okay.
Luis, you have a question?
Stuart, Alisa.
Yeah, thanks. So I just put this in the chat and was encouraged to say it out loud. And on the slide, you and in what you were saying, you talk about multiple different identifiers, but I think there's also some places where you just talk about the identifier. And I think it's pretty clear from the discussion thus far that there's like a great variety of uses of, I will say, like this information. And in some cases, it sounds like what is needed is a device identifier, and that is historically what was had. But for some of these cases, that's really not what's needed, right? Or you're just trying to prove that you're part of a group, or this is the same entity that was presented at a previous time, and these kinds of things. So I think some of the considerations on the right-hand side of the chart here are good, but I don't think anyone should assume that like a single identifier is like even the proper place to start for the solution discussion, because it sounds like there's sort of a whole API surface almost that you could imagine having that would serve lots of these different use cases, but likely reveal different information to different parties depending on the use.
Yeah, sorry if I wasn't clear. So the aim here is not to say that there should be a single identifier that replaces the MAC address. The intention of this table is to say that for each of the use cases in the bottom left, we may need a different identifier. And those identifiers will have different applicability and different properties. It may be that some of them you can solve multiple cases with the same identifier, but certainly not saying that they should all build on the same identifier, because that would essentially be a replacement of the MAC address.
Thanks, Tim.
Can you hear me?
Yes.
Okay, I just wanted to respond to the friction piece, right? I think I fundamentally disagree with that. The number one problem today is that there is too much friction and there's no consistency on how you get a secure identity onto a device, specifically a modern operating system, right? Something what I would call a human-centric device, like a laptop, tablet, or phone. That is why we could never even think about introducing any of these secure authentication methods into a home, because we can't even get users in an enterprise to do it, right? If you the shortest path to enroll as a user with a secure credential is 10 taps, and the longest path on other operating systems is up to 27. There will never be success in getting a secure identity onto these devices if that continues. And so I fundamentally disagree with that. There needs to be more friction. Like, there needs to be way less friction, because at the end of the day, you have to separate out the device identity and who, what directory or what user account that's bound to. Ultimately, that ends up being really more of an authorization decision, right? You can use the same device identity across 9,000 networks, but potentially have it tied to a different user identity based on context, right? So I less friction, not more.
Okay, thanks. Stephen?
Just wanted to note that this slide is presenting a set of requirements derived from use cases for people for whom MAC address randomization causes some issues. So it's inherently incomplete in that it doesn't kind of include the use cases for which MAC address randomization was kind of designed. So if there's something going forward, we need to kind of try and figure out what is a more complete set of requirements, including things like better privacy. And I'm not saying people are ignoring that. I'm just saying that there's a possible danger in saying that the set of use cases being considered. So if you look at the list on the left there, it's kind of the set of things that problematic in the face of randomization. And I don't think the requirements should be derived only from that set of problematic things if we decide to requirements analysis is useful.
So on that, I was kind of assuming that, yeah, we all agree that, yeah, privacy is the aim in terms of randomization, and that is a given. It needs to be achieved. So that's the reason why it's not really listed on this slide. But yes, in order to do a proper consideration, I can think, yes, it probably should be listed as, I guess, a kind of, it is a requirement in there that needs, and is probably an overriding requirement, but or at least it is the default position. And then you then are trying to figure out how do you modify that in order to meet various cases.
Sure, I understand that. I guess, it seems to me that to do a good job on this, one would also have to kind of consider what you might call abuse cases. So the kind of in-store tracking that apparently some devices do for advertising purposes. And then, because if you're going to propose some kind of change, you also want to check, does that change work well or badly for the things you don't want to happen, as well as the things you do want to happen?
Agreed.
Okay, thanks, Tommy.
All right, hello. Yeah, so could we actually go back to the table slide, if that's okay? Yeah, thank you. So yeah, following on to Stephen's point, I do think it would be useful to add more of the client privacy needs into this list as we're thinking about this as a whole. And specifically, so I'm speaking from the Apple client side, right? And what's important for me is that like any identifier metadata that's going to be shared by the client that would be consistent across networks or across different associations going forward, it needs to be based on trusting the identity of the network and trusting the identity of the particular entity in the network that's going to receive that metadata. So like here you're listing security and trust, and it's saying, how confident must the network be that the client is the true owner of the identity? And I think reflexively, we need to talk about how is the client confident about the network or the particular entity on the network that's receiving this metadata or this identity. I mean, sharing metadata needs to be done always with explicit client intent going forward, I think. And it needs to be sent in a secure way to a specific entity and not just blasted onto the network like the MAC address is. So I think we could also put on this table that we need to specify for any given piece of metadata or any identity that the client shares, like exactly what entity on the network really needs to see that to operate on it, and what are the transport and security properties that we're using to communicate that metadata.
Yeah, agreed. Yeah, makes sense to me. Yeah, the client needs to have confidence of who it's transmitting that to.
Yari?
Yari? Yes, thanks. So this is interesting. I think I'm still, like, I agree with what Tommy just said, but I think we all sort of went down to this level quite quickly. We started designing like what are the requirements and this new identifier system and so on. And I was still struggling to make a decision at the higher level, which is like, what do we actually need in this situation? Because it seems to me that we have a lot of technology. We have randomization, we have non-randomization, we have lots of sort of user or network settable configurations and defaults. We have identifiers at many levels, like the MAC and the login ID at the web page, EAP identifiers, and so on. So I'm still struggling to figure out like exactly what do we need in this space. So it isn't entirely clear to me that the solution obviously is a new identifier system. So it is of course true that people have different needs. Like you have people who want total privacy and don't suffer from, I don't know, parental control or enterprise network issues, and there are people who have those things. In this enterprise network, you have to behave in a particular way. But why wouldn't, for instance, the various defaults and settings be the right answer here, or perhaps some more information advertised by the networks that I do or I don't do these kinds of tricks, and therefore the clients could make a better decision instead of introducing a new identifier system. And I have to say that I'm also always a little bit scared about these new identifiers. I'm already identified by too many parties.
So I'm wondering whether any of the other contributors want to respond to that. Yeah, personally, I'm not immersed in IEEE enough to know to be able to respond properly to that.
Yes, Yuri here. Can I chime in?
Please.
Okay. Yeah. So I think, Jerry, I think what we try to say here is not about creating a new identifier, so to speak. I think if there is any existing technology that we can leverage here, we're happy to use it. I think we are more like looking for guidance or looking for inputs to see what, based on the use cases now we have, and based on some of the use cases is broken, what we need to do. I think I need to echo what Tommy said. We often saying that, hey, the network trusting the device, but we also want to see how the device can trust the network, so that then they can, and in exchange, they can offer something for the network to say, hey, if I know who you are, meaning that if I know this is the network I'm going to join, meaning, for example, I go into the hotel, I pay for it, and then I want to join the hotel network. And then the network may be able to say, hey, in exchange, like if let's say in that period of time, you can give me some persistent data. I mean, let me rephrase it. I would say persistent. Some data that we can use for that particular time frame. That is the service that I can offer you. And based on that contract, which if that contract expired by time, or the user can revoke that contract, or even the network can also revoke that contract, then that contract goes away. So I think that is something that, I mean, especially for the home user, they don't have a lot of technical backgrounds. They don't understand when they have a problem, say connecting a printer to the network, or the printer change the identity. And then now suddenly it doesn't know that, hey, this is a printer or this is something else. So those are the friction that we try to see, try to help the users to see if there's any better way to help them. We are not like try to reinvent the wheel if there is any existing technology that we can use. And I think what the chairs already begin, I mean, in the beginning when they mentioned the BOF, this is not a working group forming BOF. We are more like gathering information and want to hear the community how they feel about, like, is it something that we should put some energy to try to at least make, for example, like try to build a best practice or BCP or something that can help the community to ease the friction or the challenge in the future.
Okay, thanks. If you have any replay, Yari, or should we move to Tordes?
Yeah, I guess. Yeah, much of that reply was about the details of what the requirements are, and of course, you're not necessarily deciding a new thing, but maybe also think about BCPs. But I guess I'm asking, like, why isn't the defaults and settings enough of a response for the market need that we have? Because we have the people who want to be totally privacy sensitive, and they know what setting to use. We have the people who need to do their corporate network thing, and they have the setting to use already. And then there's like, maybe some people in between, a smaller fraction of the market. And it isn't clear to me, like, why would those people need some new technology or new identifier system perhaps, versus why wouldn't it be enough for them to just set the settings correctly or improve the settings or defaults. But that's just the question that I had. So but that's fine. Let's move on.
Thanks. And by the way, just as a reminder, we have a mailing list assigned for this Madinas discussion. So please feel free to ask more questions later on or during the time on the mailing list. Thanks. So we can move on. Torres?
Yeah, so one technical remark about the friction, right? So reducing the friction doesn't necessarily mean that you immediately open yourself up to denial of service attack, because I don't necessarily need to have many and arbitrary fast changing identities, right? I just want to have, frictionless identities. And, I probably prefer to have a lot more insight into, what is my user experience, right? And this may be the generic suggestion I would give. What is done here is very much trying to analyze the situation from the perspective of the provider of the use case, not of the consumer of the use case, right? So it might be good to start up putting together the aspects of what is the user experience, right? What is the friction? What is basically, the privacy that I have, right? Whom do I need to trust to keep that privacy, right? What are my processes to create the identity? What are the options for this identity to be broken in terms of to somebody mapping that identity back to me, right? So that user experience view, would help a lot to put together, exactly these user experience aspects, and then basically map between what the proposed solutions are and what the user experience is. And that's kind of, competing to what the provider of the use case, of course, wants to get.
Okay. Next in the queue, Andrew.
Yeah, hi. I think there's a lot of support for being mindful of the user experience and less friction. But really all I wanted to say, just having been encouraged to echo a point I made on the list, seems to me that this discussion is another example of where currently it's clear that developers and network operators don't really understand each other's needs and ways of working particularly well. And one observation that this discussion is achieving is at least helping bridge that gap a little. So that rather than saying how people shouldn't do things, understanding what the actual reality is, and then seeing if there's a better way of doing things rather than ignoring the reality that's there. So I just wanted to comment that I think the discussion's really helpful in getting developers and network operators talking to each other. So thank you.
Okay, thanks for that. Jerome?
I also think it could be interesting to look at these use cases from a layer standpoint. And I may be biased by the fact that this slide comes in the context of us looking at multiple operating systems behavior before, and how there seems to be no consistency between different operating systems on how they generate random MAC addresses. And by the way, there's a typo in iOS, in the iOS table. iOS does not rotate in the final version. It's more like Android, Q and R. It's sticky to the SSID, but with slight differences. But then we talked about MBO, and it seems to be an IEEE problem more than IETF problem. I see here association and post-association that smells a lot like 802.11 as well. The MAC rotation scheme for the client also, to me, is something that the IEEE is probably very interested in looking into, at least in the 802.11 context. So it might be interesting for us also to triage a little bit those layers to to see what is probably taken care of at the IEEE and what the IETF could do.
Yes, thanks, Jerome. Indeed, that's part of the questions that we would like to answer, and therefore we were very keen on highlighting the work that is that has happened at IEEE 802 and that is going on right now. But please feel free if you have more details to let people know on the mailing list. That'll be great. Tim? Tim, we cannot hear you.
Hey, so Tommy maybe kind of start churning this in my head a little bit. I think, I will be fully blunt here that I do not think IETF is the right place to address this, which I said in the chat. But if it does continue, I think we have to step further back and look at, right? One thing that's concerning to me is, and this is the problem, while I do believe something like Passpoint and secure Wi-Fi roaming is the go forward option, it does not eliminate the fact that the local network operator can see the traffic, right? It protects the identity, but it doesn't stop the fact that a local network operator can see the traffic traversing their network. And users don't know that. Users do not understand when they go to McDonald's or the Home Depot and their phone automatically connects to a network that venue can see all of their traffic. And sure, many will argue there are technologies coming, TLS 1.3, et cetera, that would make that harder. But think about how many devices spew out device names at L2 that are unencrypted, right? It would be very easy for me to figure out, even without passing a device identity, and for any form of authentication or authorization, that this is John's iPhone, right? It literally yells it to the network. So I think we have to step back and look at, to Tommy's point, how does the network identify itself to you, and what level of consent does the user actually give to these layers, and kind of to Jerome's point in a way, like where, what am I consenting to when I connect to a network? And so I think we have to address these together, because ultimately I think otherwise we're going to end up in a loop solving different problems. But at the end of the day, like today, there really is no great way for a network to prove who it is. Like there's no, it's the age old problem of, you can't really put an SSID into a cert, right? And Passpoint and Hotspot 2 and all these things have ways to potentially address them, but they're not perfect, right? And it kind of brings back the thought of like, could you bind a domain name to an SSID, right? Should SSIDs just be domain names, right? And the user can be assured that when they connect to this, they are using an identity from that domain, or that's protected, or that they've given the appropriate consent for both their identity to be shared and their traffic to be sniffed, right? Because that's ultimately what's happening.
Yeah, I think that those are good points. And just to step in here quickly, we are making sure that we don't step onto other organizations' grounds. As mentioned before by Eric, we are making sure that we coordinate as much as possible, if need be, with IEEE 802, for instance, if it's about MAC addresses or procedures on how to associate, authenticate, or and so on for a Wi-Fi or the usage of an SSID. However, we still want to understand if ever there's something, an IETF that has to be done, even if it's just informing about issues that may be opened up by identifiers that are misused. Okay, so moving on, Joey.
All right, I think it's working, so I'm just gonna start talking. Even though
Yeah,
I agree with, okay, thank you. Even though I agree with Tim, I think that the lack of end user knowledge shouldn't really prevent us from working on at least informational documents or additional options that can be used for at least some of these use cases. The purpose of the buff seems to me that it's eventually to come up with new identifiers, like Chris said. I think that for the use cases where the end user can simply not use MAC address randomization, I think at least for those, we should try to establish a clear baseline of trying to strengthen the user experience, and also to make sure that there's going to be informed consent when they choose to not use the randomization options for some of the specific use cases that were explained before. That as a minimum baseline, as we probably work towards coming up with new identifiers, or at least informational or BCP documents that would address what would happen if new identifiers become available, and if they become target for different types of abuse or tracking.
Yes, I'm just going to reply to the comment about the purpose of the BOF is to come up with new identifiers. Just want to clarify that that's not the purpose of the BOF, because in fact, what we want to make sure is that we, first of all, understand the work that is happening elsewhere, so that we don't duplicate if ever there's work happening. And as mentioned earlier on, already there's work about privacy and how to deal with MAC address randomization at IEEE 802, specifically in 11. There's 2 new parts. Also, the purpose of the BOF is basically to first of all inform of these new activities, and then inform about the issues that are happening. And it's true that right now the discussion is moving very much around the identifiers. But rather than saying that the purpose of the BOF is to define new identifiers, I think we want to understand, as for instance, Yari said, do we need identifiers? I think what we want to finally is achieve means to provide services. And we have heard both views so far. There's a device view, there's a network view, and I would actually add the user view. So right now we are just having an open discussion, trying to understand what exactly is out there, both in terms of solutions and in terms of issues, so that we can then take a decision on how to move forward, specifically on the IETF, but also perhaps just informing other SDOs about things that they may want to consider.
The only thing I would like to add is that addressing that specific question, like should the IETF get involved, at least in informational documents for this, then yes, I think yes, we should. And that's it. Thank you.
Okay, thanks, Jerry. We will actually try to get into those type of questions, but that's useful feedback. Thanks. So moving on, Xianshan.
I think the MAC address, like the IP address, is most widely used in the consumer device or in business, daily business, or even in industry Ethernet use the MAC address. So if we make some changes, I think were a lot of changes to the based on this MAC address. Like we change IPv4 to IPv6. It take a very long time. Also, we also need a consideration for the same story from IPv4 to IPv6. We need a consideration. Some device does not support this MAC address change, and we need a consideration. Maybe some support change, other do not support the change. Also, if we support this new change, we need to introduce an additional signaling traffic to identify who you are, because you change your MAC address and need to identify who you are. And maybe also needed to detect duplicate MAC address, because we assume the MAC address is never duplicated, but now making a duplicate. And in that case, we can interrupt or deny service to others, produce a duplicate address to interrupt your communication. So in such case, we need to also consider the user experience and keep service continuity. Also, as said, the MAC address is widely used in a lot of standards. I think even in 5G, in 3GPP standard, they use the 5G emulate the Ethernet network. They use the UE MAC address to add to the authentication, identification, or the packet filtering and the routing. So I think that's said before, previous before that IETF maybe is not only standard organization to do this job. Maybe we need a coordination with a lot of standard organization to do this. Thank you.
Okay, thank you. Thanks for the feedback. Bob?
Hi. Yeah, a couple of thoughts. So I'm not really sure exactly that this is something the ITF should do or exactly what it should do. It seems like in the examples on this slide, a lot of these are just, bad implementations, if I can use those words, like a DHCP server that doesn't have big enough tables to handle a lot of devices. And, MAC addresses were used for a lot of things they weren't intended for a long time. And so now they're not stable. But some of the issues that are being talked about are not just MAC addresses, like in IPv6, which, by the way, we've sort of have built support in for random MAC addresses a while ago now. We always had the notion of there being multiple IP addresses and devices could have many and you could change your interface identifier. But some of these same issues about identity and so forth apply at the IP layer too. It's not just use, MAC addresses. And so I think this needs to be thought about, broader than just, at the link, what happens at the link layer. And so I think, there's a lot of work here to do to sort of scope. Well, first of all, is there a problem the ITF can solve? Because this is sort of the boundary between what the ITF, it's not exactly ITF, it's not exactly IEEE. I'm not sure there's a good fit somewhere. So we need to be very careful to just, if we're going to do work, that it's something we can actually do and make successful as opposed to just writing a bunch of drafts that don't have any effect on the industry. Thank you.
Thanks a lot, Bob. Lee? Lee?
And here, I tend to agree that looking at all the features and the example use cases, it could be possibly related to a bunch of standardized organizations. So if we want to focus on the IETF work, probably we can start from looking at how it is related to the DHCP, because especially in the fixed network access, there are a lot of implementations like DHCP snooping and the proxy use the MAC address and IP address together, try to filter the traffic. So that could be a possible solid case that would be solvable in IETF. That's what I thought.
Okay, thank you very much. Okay, so can we move to the next slide? So we have a few questions that we would like to ask now that we have a little more understanding on the different issues and status of things. Some of these questions already we've heard, but we would like to ask them a little more formally so that we can capture a raise of hands. So the questions are, is there community interest on this topic? And here we just ask openly. for the whole community, meaning people attending here. Then the second question is going to be, are there any actions required at the IETF? We don't know actions, so don't read beyond those actions. It could be information, interactions with other SDOs, informational graph, BCPs, or so on. And finally, if people would be interested to work on this topic. So let's start with the first question. Is there community interest on this topic? And if you click on the show of hands tool, you will see there people are already clicking.
This is just a reminder, if you want to not raise your hand, there is an active choice in the show of hands tool to actively not raise your hand. Don't just wait and assume that that means your hand is not being raised.
Thanks. Okay, so the numbers are still moving. The show of hands tool is on your left top side, the graph, next to the chat panel.
The icon looks like a bar chart.
Yep. Thanks. Okay. So we close it now, and so we have 53 people raising hand, 5 people not raising hand out of 100. Great. So the next question is, are there any actions required at the IETF? And here again, we don't necessarily know what type of actions. We are asking openly whether an action is simply informing other SDOs about issues or highlighting things that they might want to consider. It could be informational drafts, it could be BCPs, or something else that we have not considered yet. So do people think that there are any actions required at the IETF? Please raise your hand if you think so, or do not. Okay, so we can close it now. I think it's stable. We have 36, 10, and 100.
Can I ask a question?
Ben, I mean, as said in the Alyssa said in the chat room, you really can't answer this question because there's nothing on the table. It needs more work first.
Sorry, I missed that. Which question you're referring to?
The second question. I mean, it's way too open-ended, in my opinion.
Okay, yeah, and by the way, we kind of left it open-ended because this is a non-forming working group BOF, and we just wanted to get high-level feedback. But indeed, depending on the results and the discussion here, we have to do our homework and perhaps go into more detailed questions. So the final question is, would people be interested to work on this topic? Is this a topic of interest to people to actually do some work? It's still moving. Okay, I guess we can close it now. We have 39, 10, 98. All right. So this gives us very good feedback. There has been a lot of very interesting points actually from people, and I think we need to look at all this information and then see how we can consider it. We are getting close to closing, and I see Yari at the queue. Yari, would you like to say something?
Yeah, just a brief comment that at least for me, the last two questions were really, really difficult. So maybe I would like to work on this if I was convinced that there was sort of a market need to address successfully. And I think we didn't explore all the questions that we would need to explore for us to answer that. But certainly more research is needed. Like, let's try to figure that out. What would make sense in this space, and not just design that new identifiers.
I would echo Yari that, like, without knowing what specifically we're planning to work on, it's very difficult to answer these questions. But in addition to Yari's point that he's interested in working on it, if there's a good proposal, I'm also interested in working on it if there's a bad proposal to try to make it less bad. I think, you know, if we see something coming out that is problematic, I do think we need to engage and reduce the harms.
Okay, thanks. Good point. Alisa?
I was thinking that maybe an action item that people can take after this is, it would be good to, I mean, we got a good overview about the related work in IEEE. It would be nice to have something similar for WBA and WFA, just to know like the scope of what's going on over there, because it does seem like one part of this is just maybe motivating the industry to adapt some of the existing technologies. So I'm happy to work with people offline to, you know, get something authoritative from those groups as well. We don't usually work as closely with them directly, but I'm sure that we can make that happen. I think that would be valuable.
Okay, thanks. I can speak as on the first part of the presentation, and also co-author of the draft. We did try to put as much information as we could on that informational draft, so that we can inform people. But yeah, if you can send some pointers or give us a name, it will be nice to get more information on that draft. Next, Haiwan Wang. We cannot hear you. Sorry, we cannot hear you. You need to press the mic. Okay. All right. So we have no one else on the queue. I don't know, Eric, would you like to say a few words?
Indeed, and thank you, JC and Carlos, for running this booth. I think it's pretty clear to everyone that many people are interested by the topic. And by the way, a lot of information was exchanged into the chat. And as we all know, the chat are recorded, so I put the link to the chat log into the minutes, so we can go back there and see the useful information that was exchanged there. Now, the real question is indeed, what do we need to do? and do we need to do something? And it's pretty clear that we have not an ideal view right now. This could come, as many people said, from documenting informational draft, BCP either for operators or even BCP for the IETF community, because it changed somehow the layer 2 and the interaction that the IP layer can have with the layer 2. So this could be documented somewhere. So it's clearly no final decision here. We most probably discuss a little bit more on the mailing list what to do next. But again, thanks GC and Carlos for running the buff.
A lot for that, Eric. And yeah, so that's a good reminder that please, people interested, join the mailing list. That's going to be the best way to move on for now with the discussion and deciding on what and if are the next steps required. So with that, thanks everyone, and good night, good morning, and good evening to wherever you are.
Thank you, guys.